Hello everyone, welcome to our presentation on Object-Oriented Programming in Java, also known as OOP. This video will introduce you to the fundamentals of OOP, explain its advantages over procedural programming, and walk you through core OOP concepts like classes, objects, inheritance, encapsulation, and more. Let's dive right in. Our focus today is on understanding OOPs in Java. This approach to programming has transformed how we write and think about code, making it more organized, efficient, and reusable.
So what exactly is object-oriented programming? Object-oriented programming is a paradigm centered about objects rather than actions. In object-oriented programming, we think in terms of real-world entities that have both data and behavior. This helps us structure our code in more intuitive way, making it easier to manage and extend over time.
To summarize, the key advantages of OOP include modular code structure, reusability, data security, and scalability. These features are essential for developing complex and large-scale applications, making Java and other OOP languages ideal choices for modern software development. Here is an outline of what we will be covering. We will start with the basics of classes and objects, followed by concepts like inheritance, abstraction, and encapsulation. Each of these concepts builds on the others, creating a framework for structuring your code. Let's start with the classes. In Java, a class is a blueprint for creating objects. It defines the properties and behaviors that the objects created from it will have. Think of a class as a blueprint for a house. While the class itself is not an object, it contains all the instructions for building.
An object is an instance of a class. Once we have a class, we can create objects that represent specific examples of that class. If car is our class, then a red Toyota could be an object of that class. Each object has its own set of properties based on the class blueprint, allowing it to interact in meaningful ways within the program. Inheritance is one of the core principles of OOP and allows a class to inherit properties and methods from another class. This means we can create a base class like vehicle and then create subclasses such as car or bike that inherit characteristics from vehicle. Inheritance promotes code reuse and allows us to build hierarchical relationships among classes.
Abstraction is about hiding unnecessary details and exposing only what is essential. It allows us to focus on what an object does instead of how it does it. In Java, abstraction is achieved using abstract classes or interfaces. For example, we might create an abstract shape class with a method draw that different shapes like circles and squares implement their own unique ways. Encapsulation. Encapsulation is the practice of wrapping a data and methods within a single unit or class. It's often achieved by making the data private and providing public getter and setter methods. This protects data integrity by allowing controlled access to the variables. In simple terms, encapsulation is like putting all the details of an object inside a box, only allowing outside interaction through designated methods.
Polymorphism. Polymorphism enables a single action to behave differently based on the context. In Java, polymorphism is primarily achieved through methods like overloading and overriding. For example, a print function might behave differently when handling text versus numbers, yet we can use the same method name. Polymorphism provides flexibility in programming and supports extensibility.
Thank you for watching our presentation on object-oriented programming in Java. We hope this video helped you understand the core concepts of OOP and how they apply to Java programming. Don't forget to like, subscribe, and leave a comment if you have any questions or feedback. Until next time, happy coding!